Hi everyone, thank you for attending our Capstone Design Presentation and Showcase. This project was a culminating design experience that gave us the opportunity to structurally design a steel structure that meets the specified requirements seen on the left-hand side of your screen. The team chose to break this design up into 4 phases to try and make it more manageable and to meet our interim report submissions. First, in Phase 1, the team focused on preliminary layout of what the building should look like and analyzed conceptual alternatives that could be done. For this, the team looked at having interior columns in the office space versus not including these columns, and from a material estimate cost, the team felt having interior columns reduced the size enough to make it worthwhile to include them. Another conceptual alternative considered was the type of truss that would be used. Originally, it was thought to compare a Pratt & Howe truss on a slope roof, but in later phases, redesigned to become a flat roof. Lastly, the team analyzed column placement and therefore created spacing between each bay and truss. The team chose a 20-foot spacing in the hangar and 15-foot in the office for ease of placement and number of columns used.
In Phase 2, the team went forward with these designs to decide preliminary members and create a SAP 2000 model so that the system could be structurally analyzed. The use of SAP 2000 was extremely important as it allowed for a 3D model to be created and decreased analysis time and complexity of hand calculations. To make this SAP model, the team had to first perform load calculations to find what forces would be acting on the system. This includes dead, live, crane, wind, and seismic. The values for what load values were used can be seen in the team's report. Next, the model was created in CAD and then transferred over to SAP, and these loads were put on the model. Lastly, the forces, axial, shear, and moment were pulled from the SAP model to be used in Phase 3 of design.
Phase 3 of the design process involved taking these force load values to size members for strength. One thing that affected these designs was the type of connection that would be used. The team decided on these connections through both an analysis period and meeting structural stability on the SAP model. It was decided that the top and bottom chord as well as the columns would need to be treated as beam columns as they were required to carry moment, but the interior web members and bracing could be tension or compression members. The team then made design sheets to check limit states and design all members for strength. The team then took these members' size for strength and confirmed that they would meet deflection or wind drift limits. Some of these members did not meet drift limits, specifically many columns, so they were resized in this phase to meet serviceability limits.
The final phase of the design involved taking these updated members and first creating a footing design for each typical column that would be in the system. From these footing designs, the team then created base plate design sheets to be used for each typical footing and column. Lastly, the team created a typical connection calculation sheet that would be used to design both fixed and pin connections at different points in the system. From this, the team was then able to make the material estimate that was shown in slide 1 and gives the company a rough idea of the material amount and therefore cost. In conclusion, the team completed these 4 phases of design to create what is both a structurally and economically efficient building to be constructed. Thank you for taking the time to listen to our proposal and the opportunity to present today.